Good morning, students. This topic, it's not there in your textbook directly, indirectly only it is there, and this part is mainly important for the NEET and JEE. For the K-set purposes, some concept point will be asked, not the whole numericals problem will not be asked, nature of the graph and what is the, at what time what is the capacitance or inductor current, like that points are there in this, they will be asked for you. But mainly important for CET, NEET and JEE, K-set purposes only rarely asked few points out of this, not the total points. For example, resistance and capacitance, multiplication as a what dimensional formula they will ask you, that is time. Inductance by resistance L by R has what dimensions? Time. This will be asked for the K-set. Next, in this resistance, capacitance, inductor capacitance connected to the DC circuit, not AC. AC already we completed in the AC topic. We are talking the DC circuits. In the case of the DC circuits, the points will be different from that of the AC relations. AC instantaneous values that with the time variable, sine function, cos function we take, but not in this case. Here we got the exponential functions, E, small e, we take logarithm functions. Capacitor is connected with the resistance and the switch here. First we connect the switch to the battery of the voltage V0. Then capacitor will be charged. Charge goes here. All the charge do not go suddenly. Charge goes slowly onto this capacitor. At any instant, charge is taken as a Q. When switch is closed, connected to B, the current is passing like this. Switch can be here on positive side, negative side, doesn't matter. And this is a short circuit for the capacitor, it is not connected here. So we are connecting only B to the resistance. But resistance what? It slows down the flow of the charges. Because the resistance charges will not be going onto the capacitor very fast, it goes slowly. And that R into C has a dimension formula called as is dimensional equal to T, time. And instantaneous charge is Q we take. After some time, long time, what happens? And one more thing, instantly just closing switch, there was no charge on this. At that instant when time t is 0, charge is 0. But after some time the charge goes on sitting on this, then charge is Q. Whenever the charges are flowing means because the resistance slowly more time is taking for the charge to fill on the capacitor, that current will be there in the circuit diagram. And resistance limits the flow of the current. The voltage is related to V equal to IR across this resistance we can take. This V is nothing but equal to IR across the resistance. But after long time what happens? After long time the charge is completely stored on the charge capacitor. The charge becomes equal to Q naught. This is a maximum charge. Q naught or peak, Q peak we can take a Q maximum we call Q peak or Q maximum or Q naught we take. Whenever the charge is full, no more charges flow into this means current will be 0 through the resistance. When current is not there, resistance should not be considered across this. When current is 0, voltage also is 0 across the resistance. And that is after long time. After long time is how much long time? Theoretically we take it as infinity. After infinite time is called as a long time. Then fully charged means charge will not flow anymore. Full charge is equal to V naught we take. Voltage across the capacitor relation is C equal to Q by V. Q naught by V after fully charged. C equal to Q naught by V naught. V naught is the total voltage across this capacitor. And instantaneous means what is C equal to Q by V. This is V and voltage increased to maximum equal to battery voltage, that is equals to V naught. Instantaneous value is QV. We take I we take and maximum is equal to Q naught V naught we are taking. After that what this is called as charging of the capacitor. Growth of the charge in the capacitor or growth or increase of the charge or charging we call it as capacitors. Next what happens is, what is done is the switch is disconnected from this B and connected to A like this. When you connect this A, what happens now? Battery is not there. The charges on this will try to get short circuited. These minus are there, electrons will go towards the plus through the resistance. Again resistance slows down the flow of charges, means suddenly discharge do not take, slowly discharge take place. Instantly charge is nothing, and instantly means at time t equal to 0, when switch is connected to A, the charge is maximum already there Q naught, voltage is V naught, but gradually what happens, charge decreases, and after some long time what happens, the charge is equals to is 0. And after long time means after infinite time, charge is 0 means capacitor is completely discharged. The corresponding equations we take is, while charging the charge formula, Q equal to Q naught into 1 minus e to the power of minus t by tau. This tau is called as a time constant, RC. R into C, resistance into capacitance, is called as the time constant, and Q naught is a peak charge. I am not giving the derivation expressions for this. Voltage, just apply the Kirchhoff's laws, you will get the expression for this. Q equal to Q naught into 1 minus e to the power of minus t by tau, you will get t is the time, after time t seconds the charge is Q, called as instantaneous charge. Q naught is a peak charge. Q equal to Q naught into 1 minus e to the power of minus t by tau. Okay, and as a this tau is nothing but equal to RC, that is a constant for the given circuit. T is not constant, it keeps on changing, but minus power is there, that comes in the denominator, we can write. So this formula can be written as Q equal to Q naught into 1 minus 1 by e to the power of t by tau. T by tau means T by RC. As the time increases, the denominator value increases. This value increases. When the value increases, the total value decreases. Decreases means what? Charge increases. Q increases. Next, time t equal to 0. Time t equal to 0. Anything per 0 is 1. This is 1. 1 minus 1 is 0. Charge is 0. Instantly, there is no charge. After a long time, t equal to infinity. This e to the power of infinity means infinity only you will get. And this 1 by infinity is 0. So, Q equal to Q naught. Equal to C equal to Q by V. So, Q equal to CV naught. This is equal to be maximum values. Maximum or peak values related to the peak voltage. Instantaneous voltage V equal to Q by C. Peak voltage V naught is equal to Q naught by C. Next is instantaneous current. How to get the current is I equal to dq by dt. I equal to dq by dt we can take. So, this becomes equal to dq by dt. Q naught is a constant term. Take it out. Integration, differentiation of this term will give differentiation of this Q naught. Q naught is constant here. Therefore, this part will be 0. Minus term comes and the integration, the differentiation of the e to the power minus t by tau minus cancels here. You will get is 1 by RC. RC itself is tau again. We can use if you want into e to the power of minus t by tau. As t increases, the current gradually changes, but at this t is coming in 1 by e to the power of t that affects the current. After a long time, the charge increases means current actually decreases. This is instantaneous current and instantaneous voltage V is equal to IR. This is across the resistance. This is across resistance. This is equal to VR. We can take I into R. I is substitution we can take. Next is if t equal to tau. This point is important for us in this topic. This t equal to tau means t equal to RC. T equal to RC, time constant. Time is a time constant. What is time constant actually is RC is defined from this relationship. Whenever the t equal to tau, this part becomes equal to 1. E to the power of minus 1 means 1 by E it becomes. So, Q naught into 1 minus 1 by E. E, take LCM, E minus 1 by E. What is E value is 2.72. It is the base of the logarithm. We generally use 2.72 just like pi. This is a constant number. Q equal to becomes equal to Q naught into 2.72 minus 1 by 2.72. E is 0.63 times Q naught. We can write this also as 63% of Q naught. 63% means 63 by 100 into Q naught. That is equal to 0.63 Q naught. The time constant. These are a definition from this we can take. Definition of time constant. Tau. It is a time taken for the charge to increase from 0 to 63% of Q naught. Charge increases from 0. First charge was not there, so charge is increasing from 0 to not maximum part. Which maximum is 63% maximum, not 100% maximum. The time taken for the charge to increase from 0 to 60% of the maximum charge is called as a time constant. And the graph, if you plot here with respect to the charge and a time relationship, this is related to the exponential. E term is there in the equation, that is called as exponential growth of the graph. This is the exponential growth graph. As the time increases, charge on the capacitor goes on increasing. And whenever the time equal to time constant tau equal to RC, the charge increases from 0 to 0.63 times Q naught, means 63% of the maximum charge. Maximum charge is nothing but equal to Q naught. This is the growth of the charge. It is called as exponential growth of curve. Next part is discharging of the capacitor. Discharging capacitor means now the switch is connected to A. Is a decay or discharge we call it as. In this case the capacitor discharges through the resistance. Whatever the formulas we have taken here, this part you have to remove it. Just Q naught into e to the power of minus t by tau is a formula you have to take for the discharging of the instantaneous charge formulas. Q equal to Q naught 1 if you remember, other one writing will be easy for you. Q naught into e to the power of minus t by tau. This e to the power of minus t by tau is nothing but equal to RC comes in the denominator. When time t is 0, initially charge already there on the capacitor, initially charge is maximum, t equal to 0, substitute the value here, Q equal to Q naught. Anything but 0 is 1, so Q equal to Q naught will get the maximum charge. Next, after infinity, the charge completely becomes 0. This is nothing but equal to minimum value. Minimum is nothing but equal to 0 charge after infinite time theoretically. Next is instantaneous voltage. Instantaneous voltage at any point V equal to Q by C. Already we discussed this. Peak value equal to Q naught by C. Peak value is nothing but max value is nothing but equal to Q naught by C. Instantaneous current I is equals to dQ by dt. Differentiation term just like before you can take only this term. Check up that relationship from the differentiation of this. Q naught comes into T into e to the power of minus t by tau relationship. Next, Here minus sign comes because Q naught is there. The definition of Q naught is 0. Here minus Q naught term is not the only variable term you will get. You check up that. If t equal to tau, again here time constant term is different. When t equal to tau, what happens? T equal to RC. Time constant in the decay cases is different, but it is also equal to RC only. This t equal to RC this becomes equal to 1, e to the power of 1. E to the power of 1 means E is nothing but equal to 2.72. When t equal to tau, Q is equals to Q naught by 2.72. And the ratio becomes equal to 2.37 times Q naught, or 37 point Q naught. This point also will be asked generally. What is the time constant of the decay? Two cases are there. While growth is different, decay is different. While decaying, initially charge is maximum, time t equal to 0. This is the time axis. Time t equal to 0, charge is maximum. As the time passes, charge gradually decreases. And after infinite time only, time equal to 0. It should not touch the x-axis, time axis. And when time t equal to tau equal to RC, while growth, the current charge increase from 0 to 60% of Q naught. While decay time, same time, time constant, if you have taken tau equal to RC after the same time, the charge is decreasing from maximum to 37% of maximum charge, or 37% of Q naught is nothing but equal to RC. So decay time, decay time, in the case of the decay and in the case of the growth, time constant is different definitions we have. While growth is time constant is the time taken for the charge to increase from 0 to 60% of Q naught, while decay, the time taken by the charge to decrease from maximum to 37% of the charge. Next is when these two graphs coincide at this point. This is not asked till now. In case if you ask, you must know. But when these two are coinciding means you have the same charge here at this time t. At the time t, the charge is q. So in both the cases, charge is same means you have to take that two equations equate. Q equal to q naught minus t by t is equals to q naught e to the power minus t by t. You will get the expression as the time is equals to 0.693 times tau. These are expressions for resistors, capacitor in the DC circuits. Where we use this time constant related is timer circuits. After some time we want to switch on the power supply in the house, the power supply for the bulbs, etc., or vehicle side lamps on off after particular time on, particular time off. On means that case of discharge time connected to the output bulbs. So through the bulb resistance filament, the bulb capacitor discharges, bulb glows. While charging time, bulb do not grow. So charging on off related to this charging and discharging of the capacitors. In the timer circuits they are used. Next part of this circuit diagrams. Previously, please check up that I done mistake. LC I wrote. LC circuits already inductor capacitance. AC circuits we have completed. It is RC or LR. Resistance capacitance, inductor resistance means RL we can write or LR we can write. The second part of this topic, we take inductor connected with the resistance in series with it. Sometimes inductor is a coil only. Wire in the form of a loop is called as an inductor. Any coil is solenoid is inductor. Inductance is L. If this wire has a resistance R, that resistance comes in series with the external resistance. So total resistance, where in the formulas we take it as R plus R. If the ideal inductor mentioned means this R equal to 0 for ideal cases. But practical cases, every wire has some resistance. Unless you take this wire at absolute 0 temperatures, then superconductor resistance only 0. Otherwise, this is only for ideal case R is 0, otherwise total resistance becomes equal to R plus R. That is the internal resistance of the inductor is taken as a smaller. And the inductor connected with the resistance R is with a switch and along with the batteries. As the battery connected with the inductor, the current try to increase through this. When your switch is closed, try to increase current. When switch is short is connected with this A, short circuit case current try to decrease to the inductor. Now we have to take the help of the Faraday's law of electromagnetic induction taking place. In the case of the instantaneous current, if you take that same similar formulas like charge you have taken for the capacitor, no, Q equal to Q naught into 1 minus e to the power of minus tau by tau. This becomes equal to, wherever Q is there, replace with current I equal to I naught into 1 minus e to the power of minus t by tau. But tau, time constant for the resistance is RC, but time constant for inductance is L by R. What is time constant? At the end we discuss. The time constant is taken as a tau here, it is L by R. So L by R, RT by L it becomes the formula. I equal to I naught. I naught is the maximum current that can pass through the inductor. 1 minus e to the power of minus t by tau. I naught is the peak current that can pass through the inductor, and peak voltage across that is nothing but equal to V naught, that is the battery voltage. R, resistance always opposes the flow of the charges. So slowly current increases. When next time t equal to 0. When time t equal to 0, anything to 0 is equals to 1. So this 1 minus 1 is 0, current is 0. Initially there was no current. That means when you switch on, at the instant switch is closed, current try to increase, but current is 0 here, but this one opposes that current. What happened is back EMF is produced exactly above this external cell EMF. Try to go this side, back EMF is produced in the exactly opposite directions, and that induces the current. It's only opposing this current also at the instant only, not for a long time. At the instant when switch is closed, current is 0 through the inductors. So back EMF is produced. That back EMF is nothing but equal to back EMF is minus V naught, opposite to the external battery voltage produced. After t equal to infinity, long time, slowly the current increases. After long time, what happens? Infinity current becomes equal to maximum. It's just like a wire, just like ordinary resistance wire, it becomes and current becomes equal to maximum through this inductor. So we are taking the current through this inductor as I at the instant. I is 0 at the time 0, I is infinity at time t equal to infinity, I equal to I naught, that is the maximum current we can take. What is the maximum current is equals to V is equals to IR formula we can take. Maximum current is limited only by the resistance R, so V naught is equals to this I naught into R. But instantaneous current is limited by the resistance also, back EMF of the inductor also. But maximum current means what? Inductor do not oppose the constant current after a long time, but opposes only changing current. So instantly current is trying to change means back EMF is produced. If current try to decrease means forward EMF is produced, which changes try to change the current, opposite change of the current. But now after a long time the current is constant. Constant current is not opposed by the inductor. This presence you have to neglect. Only R is the one which limits the current. V naught is equals to I naught R. This is the when time t equal to infinity. I equal to I naught, and voltage across the inductor is 0, and instantaneous voltage V equal to V naught into 1 minus V is equals to IR, only formula we are taking is related, but the relation for the total, this is for the inductance, V equal to V naught into 1 minus e to the power of minus t by tau. Tau is L by R, go to the here, this is across the inductance place. 1 minus e to the power minus t by RC equal to V is equals to I into R. Okay, this one at the instant, the voltage across the resistance if you want to get, no. So voltage across resistance I equal to R, this VR is equals to I into R we can take. Instantaneous current is resistance across the resistance. But for the AC circuits we don't take like this. What we take the AC voltage? Voltage across this one square plus voltage across this one square under root is the total voltage we have taken in the case of AC current. But in the connected to the DC, we can add the two voltages directly. Voltage across this plus voltage across this equal to voltage across the battery cell. That is total voltage. V equal to V1 plus V2 you can take for the DC circuits. Next, when time t equal to 0, current is 0. This is a time constant relationship, and for voltage also we can take when one time t equal to 0, what happened to the voltage, after the infinite time what happened to the voltage. Next is time t equal to 0. This is for the time constant. Time constant for the growth of the current. When t equal to tau, it becomes what happens? This is going to be minus 1 by E it becomes. So I equal to I naught into 1 minus 1 by E, it becomes same thing for the voltage also. I equal to I naught into E minus 1 by E. What is the E value? E value is 2.72 constant terms. Putting the value into this, you will get the current as 63% of I naught or 0.69 I naught value you will get. That is related to the time constant. Means time constant depends on the time in which the current growth. The current increases from 0 to 63% of the maximum current. So growth of the current graph is same for the capacitor RC circuit and also LR circuits. There we, for the RC we have taken the charges here. Here we, in this case we are taking the current I. That is only the difference. Remaining all term symbols remain same. So I naught, because the growth of the current is increasing gradually, exponential growth. Exponential graphs we called as a exponential growth, exponential decay. Exponential growth graph is like this, and time constant, time t, when time t becomes equal to RC, the current increases from 0 to 63% of the maximum current. Next is a decay of the current through the inductors. What do you take the switch connected to the A, it get the decay. Previously for the charge, now we are talking about the current. Flow of the charges with time is nothing but equal to current relationship for the inductors. So here what happens when you connect to this A, now inductor try to discharge, means in this already having the current stored in this form of the electromagnetic field, magnetic it behaves like magnetic field is there, magnetic energy is there. Now the current will try to decrease through the inductor. The current is trying to decrease means the induced EMF is going to be forward EMF which opposes the decrease of the current. but it cannot stop for a long time, and current will be slowly decreased with in terms of the resistance. More resistance, more time it takes, less resistance, less time it takes. So decay of the currents, similar formula we take, this I naught 1 minus won't be there, just I naught into e to the power of minus t by tau. Tau is nothing but equal to L by R. Time constant is L by R in all the cases. For the RC, tau equal to RC for the resistor capacitors. When time t equal to 0, discharging cases, no, current was initially maximum, I equal to I naught. After a long time, current decreases completely to 0. Next, voltage V is nothing but equal to across the resistance is nothing but equal to V equal to IR will get, and voltage across the inductor is nothing but equal to V naught into e to the power of minus t by RT by L. When time t equal to 0, voltage across the inductor, this part, this voltage across the inductor, when time t equal to 0, V equal to V naught, maximum voltage, after infinity current is 0, so voltage across the inductor is also 0. This is for inductance, instantaneous values. Next, time constant for the decay cases. Time constant for decay cases is when time t equal to tau, time t equal to tau, this space, e to the power of minus 1 it becomes. So I equal to I naught by, I naught into e to the power of minus 1 means I naught by E. E is 2.7 to substitution, you will get I equal to 0.37 times I naught, or 37 times I naught for the decay of the currents. That means time constant for the decay time is defined as the current, it is the time taken by the current to decrease from maximum to 37% of maximum current is the time constant. Again, same as before, if the two currents graphs are coinciding at what point means at the same time, same current we have to take, I and T same, equating these two equations will get this time taken for the coinciding is 0.69 times T times tau, but is not important for us. Next we have to work out some just 1-2 problems. Just 2 example problems I will discuss. Remaining I will give the hints in the assignment, you can go through that. 2 inductors of different materials have same inductance. They have the same inductance, L is same, L1 equal to L2, but different metals are made, means resistance can be different. The time constant ratio is tau 1 by tau 2 is 1 by 2, 1:2. Find the ratio of the resistances. The 2 coils are given, external resistance not given, since wire resistance only you have to take the internal resistance R1 and R2. Can be taken capital letters or small letter left to you. Time constant tau equal to L by R. I am taking here R is a small r ones. So here tau 1 by tau 2. So this resistance I will take it as R1, this as R2, internal resistance. Wire internal resistance. The ratio of the time constant tau 1 by tau 2 is equals to L1 by R1 into denominator is L2 by R2. R2 go to the numerator. L1 by L2 into R2 by R1 comes. But what they told is same inductance, means they have given L1 equal to L2, that cancels. Inductance value is same. Inductance depends on the wire dimensions, physical dimensions of the wire, number of turns only, not related to the resistance of the wire. So and do not depend on the current also, we have discussed already in the electromagnetic inductions. Next, time constant ratio is given as 1:2. You are given as tau 1 by tau 2 is equals to 1 by 2, it is given for us. So 1 by 2 is equals to R2 by R1. They asked is resistance ratio. So L1 by L2, tau 1 by tau 2 you are taking means R1 by R2 is show, that is nothing but reverse of this 1 by 2, which is nothing but equal to 2:1. Next problem. A coil is connected to the ideal battery. Ideal battery means internal resistance R equal to 0 for this. Of 12 volts. Current grows from 0 to 63% of the final state. Indirectly they have given that time taken T equal to tau. They don't give the time, but they are given indirectly as 63% increase or decrease for to 37% means T is equals to tau, it means, which is nothing but equal to 0.3 seconds they have given. And find the final steady state current, means constant current, is 0.6 amperes. Find inductance of the solenoids. L you have to find out. The time constant formula tau is equals to L by R we have. R is not given for us. R here is external resistance not mentioned, that means we can take external resistance or wire resistance only we are taking here. Wire resistance if you take this R, internal resistance, V equal to IR formula we have, this V naught peak values, that is current given for us at the end. So R equal to V naught by I naught. So if the values here eliminate R is equals to V by I, V naught by I naught. So internal resistance of the this battery cell are equal to 0. In case of the battery, resistance also comes, no, that comes in series with the resistance of the solenoid. Any resistance given, take them all in series please. Don't take parallel resistances, take only series resistance which is series with the inductor or series with the capacitors. Now given time constant is tau equal to 0.3 seconds and voltage, maximum voltage is 12 volts, that is EMF values, because internal resistance 0 of the cell means ideal cell the voltage and EMF are equivalent, and current, peak current is 0.6 amperes. Put the values into this expression, you will get 0.3 equal to, you are asked to find out inductance L by V0. V0 is 12 into I0 is 0.6, decimal cancels, so 3, sorry, we'll take this L equal to 3 into 12 by 6, 6 to the 12, L is equals to 6 Henries is the answer. We'll stop now. Next class we start the new topic.